This video from ITT Flygt is primarily for operators of flight equipment in drilling mud applications. We'd like to show you how to avoid shutdowns by using our products the right way. Handling the equipment wrongly may lead to unnecessary and expensive downtime. Hi, I'm Kim Loughran. In the next few minutes, it'll be my pleasure to give you a few tips on how to use your equipment best. But this video is only a complement to the printed product information, so you should read that too. Basic drilling mud combines water, light base oil, usually diesel, or synthetic fluids like esters or ethers, and bulk additives such as barite and bentonite. High-density barite gives the drilling mud the required density. Bentonite is added in different proportions to produce mud with specific viscosity and gel properties, which provides the rheology, or how liquid reacts to mechanical stress. The power consumption of the mixer increases proportionally to its specific gravity. A mud's specific gravity of 1.5 will increase power uptake by 1.5 times its use in water. Thrust is the force used to mix and create the jet to maintain a properly mixed drilling mud solution. The produced thrust increases proportionally to the specific gravity, which ensures that the mixing result is also independent of the specific gravity. A mixer used in drilling mud has to be properly selected for the intended mud by the rig's design engineers to avoid overload. If the specific gravity of the mud is higher than specified when the mixer was engineered by ITT Flygt, it might overload. Thrust is thus not a problem, since it increases with increased specific gravity. It's important that the mixer is always submerged. If it isn't, it'll overheat. To choose the right mixer, we need to know the mud's viscosity. Viscosity is a measure of how easily flows mix or how thick the fluid is, and it affects the performance of the mixer. High viscosity increases energy consumption and decreases the thrust of the mixer. Yield stress is the resistance that has to be overcome before the liquid can begin to flow. Yield stress is the main sizing variable when selecting a mixer for drilling mud. The higher the yield stress, the thicker the mud, and the more difficult it'll be to mix. So, if yield stress is higher than the value used when the application was engineered, the mixer won't be able to treat the whole load. Also, if yield stress is too high, making the mixer undersized, the flow in the tank, and especially the backflow to the mixer, will be weak. This may also cause overheating, because circulation around the motor housing will be insufficient. Let's relate these issues to your workplace. There are 5 different locations where drilling mud is processed. The mud plant, the onshore plant where the mud is manufactured. There are preparation tanks and storage tanks with submersible mixers. The supply ships, which deliver everything necessary to keep the rigs going. Drilling mud is one of the cargoes. The submersible mixers are located in the storage tanks. On the drilling rigs and drilling ships, there are storage tanks, active tanks, and tanks for cutting storage, each with submersible mixers to keep the mud suspended and prevent solids from settling out. These are complex installations because mud properties vary a lot depending on geological conditions at the drilling site. And finally, in the mud recycling plants, used mud is cleaned and prepared for reuse at your worksite. Guide bar is the standard installation for Flygt mixers. This is the normal installation method for rigs. In the examples mentioned, guide bar installation can be used only on rigs. Install the mixer so that it's lowered to a physical stop before the propeller hits the bottom of the tank. On supply boats, it's necessary to use a floor stand where the mixer is firmly fixed to the tank floor. To support your installation, ITT Flygt can provide suitable lifting equipment such as lifting davits, winches, blocks, tackles, and chains. We can cover a wide range of different weights. The mixer can be installed on the guide bar in a horizontal position or with a standard angle of plus or minus 10 degrees or plus or minus 20 degrees. Check that the mixer travels up and down the guide bar easily before lowering the mixer to the required working depth. We recommend different oil quantities in the mixer oil chamber depending on the mixer position. An example, the oil quantity for a 4660 positioned at 0 to plus or minus 20 degrees is 1 litre or 2 pints, and for minus 90 degrees down, increase to 1.5 litres or 3 pints. For more information, please read the Care and Maintenance Manual. The mixer should always be lifted from a point that represents its centre of gravity. A tape on the mixer indicates the position of the lifting handle for different angle positions. When installing the mixers, make sure that the cable cannot be pulled into the propeller. Always use the lifting device to lift the mixer, never the cable. Thermal switches, which control the stator's upper temperature limits, are a standard feature on all mixer stators, whereas FLS sensors for the detection of liquid in the stator housing and CLS sensors for water and oil detection are optional. Any combination of these sensors supplied with your mixer must be properly connected to a monitoring and control system to avoid damage and to make the warranty for the mixer valid. The explosion-proof mixer is restricted to the use of thermal switches with or without FLS. The CLS is not explosion-proof and can't be used in this area. The sensors are monitored by the ITT Flygt minicast supervision relay and should be interfaced with your control panel. If the sensors to the supervision relay minicast are not properly connected, the mixer may sustain damage. The mixer must always be submerged. It's designed to be cooled by surrounding media. In air, cooling will be insufficient. You'd run the risk of the stator burning up, which means extremely expensive downtime. If the propeller is too close to the surface when running, a vortex can form. This will draw air and swirling flow into the propeller, causing vibrations and thereby drastically shortening the life of the mixer seals and bearings. ITT Flygt can always give you the minimum recommended submergence. The use of a Flygt vortex suppressor will allow the tank to be pumped down further while the tank is being emptied. Additional cooling can be provided to the flange-mounted mixers by using a cooling jacket in which cool water can be circulated. As I mentioned, the mixer must always be submerged to get sufficient cooling and for proper heat transfer to occur. And if the yield stress of the mixer is higher than it was designed for, the flow around the mixer will be too weak. Special jet rings, extended jet rings, should be used in thick mud in order to pull flow around the mixer and keep it cool. If the indicators in your control panel generate an alarm, do not ignore the alarm or override it. Attend to the problem to avoid unnecessary breakdowns. Before starting work, make sure the mixer is isolated from the power supply and can't be energized. Depending on the viscosity and specific gravity of the mud, the choice is between a 2-bladed or a 3-bladed propeller. Propeller standard material is stainless steel 316L. For recycled mud or abrasive environments, the 3-bladed high chrome propeller is recommended. This propeller can handle higher specific gravities. The recommended cable is a heat and resistant cable, the HCR. This will work in all chemical environments for drilling mud applications and also handle high temperatures. It's also possible to use the Flygt subcap cable in many applications. However, the temperature must be lower than 70 degrees Celsius or 160 Fahrenheit, and the need for chemical resistance must be moderate. For instance, the subcap can't be used in oil-based mud unless it's protected with a certain steel shelting. And in abrasive environments, or when cleaning chemicals are used, cable protection such as the Flygt metal hose or its equivalent is recommended. The Flygt plug-in seal with tungsten carbide seal rings is the recommended seal type for most applications. Since flammable vapors or liquids are present in many of the environments where mixers are located, explosion-proof mixers, known as EX-approved mixers, are strongly recommended. The explosion-proof version is designed for use in explosive environments in accordance with factory mutual standards. All interface areas between components are very narrow, so it becomes impossible for sparks to escape to the surrounding medium. EX-approved products are also designed to withstand high inner pressure. A good indication of how well we've done with the EX-approved flight mixers is the American Bureau of Shipping's stamp of approval. All work on the explosion-proof motor section, including the installation of electrical connections, must be carried out by personnel who are EX-proof qualified and authorized by Flygt Corporation. Work outside the approval parameters, for example changing propellers or plugging in seals, can be done by non-authorized personnel. Thermal contacts must always be used on EX-approved mixers because of the approval conditions. One extra data plate is delivered with each mixer. A good idea is to put this additional data plate by the installation panel so that electrical data for the installed product is easily accessible. Always save the product documentation. It'll contain all the information you'll need. Always keep basic spare parts in stock. Downtime in your operations costs big money, but the more preparation you do, stocking the right spare parts, doing service training, and why not stocking a spare mixer, reduces these costs. And since the job you're doing is being done all across the world, we're global too. There are ITT Flygt retailers all over the world, so when your spare parts stock needs replenishing, we're there for you. Please follow these recommendations. They'll ensure trouble-free and economic mixing operations wherever you are, on land or sea. Good mixing from people who care about you.